Hello and welcome everyone. Today's webinar is provided to you by the International Knowledge Aware Association, which is a nonprofit organization built to assist organizations in transforming through knowledge aware concepts. Today we'll be covering creating a learning organization through AI. Before we dive into the content, let's take a minute to go through introductions. I'm Brittany Satterfield, the Board Secretary of the IKAA, and I'll be your host for this afternoon's webinar. With me today is one of the IKAA's founding members and CEO of Oros Knowledge Systems, Jeff Maffa. Jeff has over 15 years of experience with the knowledge aware approach and has been one of the primary contributors of the concept of knowledge aware. As always, it's great to have you back, Jeff.
Thanks, Brittany. Glad to be here.
So today we're going to start off by running through a brief introduction to the knowledge aware approach. Then we'll review the flow-based requirement management model, then dive into the AI-assisted learning cycles. And following that, we'll open up to Q&A and share where you can find additional resources following today's session. And before we move on, I want to quickly point out that you don't have to wait until the end to ask your questions. You can type them in the chat box at any time and we'll answer them at the end of the session. So Jeff, I know that many people here have already heard about the knowledge aware approach before, but there are some here that have not heard about what knowledge aware is. So that everyone can get up to the same speed on what we're sharing today, can you go through a brief introduction on the knowledge aware approach?
Thanks, Brittany. Before we get into the explanation, let me just remind some of the listeners that there is a dedicated webinar on the topic that gives a good overview of the concept. Here I will be brief, but for the listeners that are looking for a deeper explanation of the general concept, I would point them to those webinars in the series available from the International Knowledge Aware Association's website. Okay, let's proceed with a brief explanation of the knowledge aware concept. So the way we always explain the knowledge aware concept, it's actually quite simple, and it is the difference between paper maps and navigation. So the way we traditionally managed knowledge was akin to the paper map. It's a documentation of knowledge. In the case of paper map, it's all possible turns at a specific point in time. And when you think about it, document repositories are like that. They contain everything that's been documented, but it's all relevant to specific periods of time. A document contains a lot of information. It's very difficult to upkeep all that information all at once. And people generally find this useful, but is it the best way to actually manage knowledge? And the answer is no. And the proof is that we all now prefer to use navigation, right? The navigation metaphor and technique is far better. And there's two reasons for this. One reason is it doesn't, instead of giving you all of the turns possible in a given area, it only gives you the turn that you need next. And again, the next turn. And what's really happening here is that the navigation app is taking in context from your cell phone, GPS, where you are, and then is able to provide to you just the right information at the right time. Okay, I said that there was two reasons why it was really important. The first, already talked about, the right information at the right time. But the second, and it's going to lead us very much into today's webinar about AI-assisted learning organizations. The second is that the Nav app is taking in information and data about what other drivers are doing, and it's turning that data and information into useful insights, value-added insights, valuable to the driver. Those are estimated time to arrival, traffic, and all kinds of and map improvements, right? So that data about how knowledge is getting applied, about what turns are actually being taken, about what driving speeds are actually happening at the moment are very important pieces of insight that are derived from the data of people using the map itself in real time. So that's really what the knowledge aware approach is about, and it's about provisioning knowledge as it's needed and improving the knowledge as a result of tracking what actually happens to the knowledge, producing insights based on what actually happens to the knowledge. So today we're going to talk about AI-assisted learning cycles, right? And that's akin to how Google Maps may actually improve their turn directions by understanding what drivers are actually doing given the instructions that they had. Before we conclude the overview, however, I want to point out not to take the navigation metaphor too literally. the knowledge-aware technique isn't necessarily about giving step-by-step instructions like navigation, but rather it's about how units of know-how or requirements can be provisioned as and when it's needed, like navigation, and that it's active from the end user's perspective.
So before we go into the flow-based requirements management slide, I want to point out that this slide might look a little familiar to those that attended our webinar back in August. So we're going to go through the same slide, but this time concentrate on how the flow-based model will naturally create learning cycles. And I think it's going to be real interesting for many of you. So Jeff, you want to start off by reviewing through this flow model itself?
Sure. So here we can talk about it as a requirements flow model or a knowledge flow model. I think depending on your own perspective, one or the other will make sense. It depends really how you define knowledge or how you define requirements, but it works in either case. Okay, so the starting point of the flow-based model is the idea, which I believe is self-evident, that the modern engineering-intensive or technically intensive company is become or has become model-based. The idea is that models have become pervasive, and these models then are the foundation for the opportunity of the flow model for knowledge and or requirements. So everything that happens in an engineering or technically intensive enterprise goes through or passes through some type of model. In engineering worlds, CAD's a model, CA's a model, PLM's a model, ERP's a model, manufacturing execution is a model, etc. So models have become pervasive and the foundation of the way the engineering and decision-making process happens. And now let's look at the flow model that must attach to it. So there's a knowledge or requirements ecosystem, and that ecosystem looks like this. There is a top-down flow of requirements. We typically call this a flow-down process. In a more detailed explanation, I would actually separate flow down into two separate streams, but that's another topic for a different day. So the flow-based model introduces the concept of flow up. The flow up process is how do we meet requirements that are flowing down. It is essentially the knowledge management portion of knowledge and requirements flow. And importantly, the flow up process is very different than the flow down process. The organizational learning cycles are very different than the way requirements are created and consumed. It has a very different life cycle, very different needs, and there are established practices to better do flow up that are very different than flow down. We add to flow down and flow up, flow in, and flow in, similarly to flow down and flow up, are just a different flow of knowledge from external sources, maybe first principle type knowledge or from external standards organizations that need to be applied orthogonally to flow down and flow up. But what we need to do to these three streams is to integrate them into a single unified stream of knowledge or requirements readied for reuse in a way that the model-based enterprise can use that knowledge directly. And you can think of this concept as knowledge as a service or requirements as a service, where now we can provision units of requirement or units of knowledge into the model-based process where they can be evaluated and applied and data collected about them. So now you're starting to see the similarity with the navigation, right? So map tiles and turn directions are provisioned as you need them as unitized structures. It doesn't care what specific route you're on. The turns can be provided, the map tiles can be provided based on an abstraction of how the map tiles and turns will interact with your context. And that's what the suggestion is here, is that the requirements can be unitized in a way that are abstracted so that they can be applied to the model-based environments in real time without wiring them into the model-based process. Okay, and now we're getting to our topic of the day, is how do we now learn from that through AI? So we alluded to it that the navigation app has this already built in, but the idea is that if the knowledge is being flowed into the models, we now can track data about how knowledge and requirements get applied, and then use that in a flowback process of creating learnings that then become participants in the flow up process and are applied to future projects, processes through the same mechanism. Okay, so we're going to talk a little bit about the learning cycles here in a second, but let me provide a bit more detail about what makes this possible. There are three primary elements of data collection that become available that are imperative to make AI work in these learning cycles that we're going to talk about. The idea is that there's a unitized bit of knowledge, something that's specific enough that provides information to the AA process. 2, context about where and what that knowledge is going to be applied to. And 3, the outcome of how the knowledge was being applied. So I call this the trifecta of data collection that enables AI. AI is primarily a data-driven process, and this is the data that you need, that only the knowledge-aware process enables the collection. So in the Nav app, the context is what trip are you taking, where are you, what time of day. The knowledge is the turns that are being suggested, and the outcomes are the turns that you took. And with that information, Google is able to refine maps and understand and go apply different processes to understand what's wrong with a turn algorithm, what turns can be added, what might be wrong in the map data. And that is AI assisting the learning of the system to produce better turn directions in the future. So we can do the same thing with requirements and knowledge. We can understand what unit of know-how is being applied, what context was it applied into, and what was the outcome. And we can use AI then to produce better knowledge going back into this process as a cycle. So let's talk about specifically how that's done. So today, the primary emphasis is on this idea of AI-assisted learning cycles. And the AI-assisted learning cycle looks something like this. Let's start at 12 o'clock at the top. The first step is fundamentally an AI-assisted process. It is the identification of what we call a learning opportunity. So we can take the trifecta of AI data, the unit of learning, the unit of requirement or knowledge, the context, and the outcome of the application of that knowledge in that context, and use AI to find high probabilities of a learning opportunity. The next step is stakeholder and identification of team members. Again, AI can be used and applied by looking at the characteristics of the learning opportunity and understanding who's participated in similar knowledge through AI. We can use this data to identify specific people that should be alerted to the identified learning opportunity. So we suggest a number at IKAA, we suggest a number of different processes that would make this work and how it can work in a practical sense. But in an abstract sense, it's basically identifying the learning opportunity first and then identifying people that are relevant to that AI, to that learning opportunity through AI techniques. And this is relatively pretty straightforward AI to be able to do this. Okay, the next step is now in the current state of affairs manual process, where a team that's now been identified can look at the learning opportunity and extract from that learning opportunity formalized conclusions, what really is the conclusion of the learning opportunity itself. And there may be more than one. So the team now, through human intervention, identifies a specific conclusion to be applied to future engineering or technical decisions. And the next step is to take those conclusions and to create new units of know-how, new requirements. And again, this is the idea of creating retained know-how that's kind of knowledge-aware speak for taking what's been learned and unitizing it in a way that it can be provisioned in the future. It's like the last step, Google has decided that there's a change that needs to be made on a map tile, and the creation of the retained learning is the actual changing of the map tile or the turn direction algorithm, that nudging of the algorithm so that it produces a better result in the future. So this is a mechanical process of creating the digital footprint of the conclusions of the learning opportunity. So now the knowledge-aware process takes over and distributes and provisions the new know-how in the way it provisions other know-how and requirements. So the knowledge now ready for reuse is provisioned to where and when it's needed to improve engineering decisions and outcomes, similar to all the knowledge that's being captured and retained in the knowledge-aware process. And of course, that produces more data about knowledge reuse that can be collected and then used again as input to the creation of the learning opportunity. So we do have good examples of this working in practice, and the results have been phenomenal. We really can understand knowledge that is missing, knowledge that needs to be created, recurring problems, all can be identified through this AI-assisted learning cycles approach that's fundamentally enabled only by implementing a knowledge-aware type process, where the trifecta of unit of knowledge, its context, of application, and its outcome are available to be analyzed through machine learning techniques. So we're back to the flow diagram, and what we see is that the learning cycle that contained the steps we just went through really are this same set of three arrows, where the knowledge ready for reuse is provisioned into the model-based enterprise, and the models then are applying knowledge, and we're collecting the data, the trifecta of data required for AI and machine learning. We're taking that data and producing learning opportunities, and through the formalization process and the capture and retained know-how process, we're creating flow back. And once it's flown back, it's available for the flow-up process where it's provisioned and again readied for reuse into the model-based enterprise. So the learning cycle process is just a different view of the bottom arrows in the flow model.
All right, thanks for that, Jeff. So before we go into Q&A and close out, can you take us through a quick recap on what you just shared?
All right, thanks, Brittany. These are the primary takeaways or conclusions we hope the listeners have come away with. 1, the knowledge-aware approach uniquely enables closed-loop learning. So again, the reason is to have AI-assisted learning, you got to have the data. That's true for all machine learning. It's all about the data. And unless you have captured knowledge in the right way and can marry it with context and outcome, there's really no or very little opportunity that I'm aware of to use machine learning to create learning cycles. 2, the knowledge-aware approach creates data that is leveraged by AI that AI cannot do it alone. Again, this is a little bit similar to the first one, but it's really about the data, and the knowledge-aware approach uniquely enables us to do that. And 3, AI-assisted learning cycles will create a competitive advantage for any engineering-intensive company that adopts the knowledge-aware approach. Now, we didn't state this explicitly. My hope is that it's self-evident, that if one company has produced the capability to, through AI, to understand in real time where recurring problems are happening, where knowledge needs to be adjusted or technique needs to be adjusted, that company will have competitive advantage over the one that doesn't. And I think this is a compelling argument that deserves any engineering manager's attention because it is the future. At least it's my belief.
Okay, as you guys can see, now it's time for the Q&A session. So at this time, if you have any questions, please go ahead and type them in the chat box at this time. For now, we're going to get started with the questions that were sent in earlier. The first question is closed-loop learning a thing of the future or something organizations are doing today?
That's a great question. I would say it's a thing of the present. Maybe it's not a thing of the past. It's not mundane. Everybody's doing it. But I think there are clearly some use cases that are in production that have proven the value. I think there's a long way to go before the full vision that I presented here is materialized. But I think the opportunity is at hand, And I think the opportunity is at hand and compelling.
All right, thanks, Jeff. So this one just came in. What is a unit of knowledge?
Okay, so the unitized bit of knowledge, I think I use that term quite a bit today, and it does deserve some more explanation. Those of you familiar with the knowledge-aware process or the knowledge-aware concept probably already recognize that is what knowledge-aware calls a knowledge packet. And there's quite a bit of explanation about what a knowledge packet is in the knowledge-aware literature, but basically it's the way to capture knowledge in a durable format that produces uniform, active, granular structure that allows the knowledge to be provisioned. So, for example, the map tile is just an easy way to explain it in navigation, right? So the map tiles are at different levels of resolution based on your zoom level. They have metadata on them so they know when to be provisioned based on where the map is centered that's being demanded. And in the same way that the knowledge, and it needs to be presented back to the technical processes as a unitized, granular bit of knowledge that can be provisioned as it's demanded based on context. And the knowledge packet or the unit of knowledge is the way that the knowledge-aware process gets that job done effectively.
All right, here's one more question. How can we use AI to select members of the team?
Yeah, that's a good question. So it's actually a very similar machine learning process, AI process that the learning opportunity itself is identified. The trifecta of data is not required here, but basically, when you have units of knowledge published and you have the knowledge being reused and the context being captured, think about it. So now a learning opportunity has been identified through machine learning. It's a very simple machine learning technique now to then go to the knowledge space, the units of knowledge, understand who's authored, who edited that type of knowledge that's relevant to the learning opportunity. We can look at issues and we can look at application of knowledge and who those participants were. And those participants that interacted with similar knowledge are candidates to be a participant in the learning cycle. So again, it's all about collecting the right data to make this an AI-enabled process. And the knowledge-aware process, by creating units of granular know-how and understanding who's editing, who's authoring, who's applying, can then match people to the learning opportunity.
All right, so it looks like we were able to answer everyone's questions for now. If you do have questions that do come up later on today or this week, go ahead and send us an email at info@knowledge-aware.org, and we'll be happy to answer your questions. So I want to be respectful of everyone's time. We're going to move on at this time. So if you're interested in learning more about the knowledge-aware approach, I want to encourage you to join as a member of the IKAA. Members have access to tons of great resources, past webinars, conference discounts, and more. To learn more about the IKAA memberships or to join as a member, visit knowledge-aware.org. So that's it for today. So I will be sending out recorded copies of this webinar later on today, so you will have access to that so you can share it or watch it again later. If you can, take a minute to complete the survey that does pop up when you close out. Your feedback will be greatly appreciated. And like I mentioned before, if you have any questions that come up, you can shoot us an email at info@knowledge-aware.org. Thanks for coming, and we hope to see you in our next webinar in January. Have a great day. Bye.